Hello there, and in this video we're going to cover our final sort, the Radix sort, or Radix. The Radix sort is a sorting algorithm where elements are sorted by their place value, where we go from the least significant digit to the most significant digit. So what does that mean? If I had a number like 543, for instance, we would start here because the 1th place is our least significant digit, versus the 100th place is our most significant digit, right? Because if we break this apart into its actual values, this is 500 plus 40, this is plus 3, right? That plus 3 is a very minuscule difference, right? Compared to this plus 40, and especially this plus 100. That's what I mean when we say this 5 is the most significant. It's significant because it adds the most to this value, and 3 is the least significant because it adds the least to that value. Okay? Or you kind of just view it from going from the 1st place and then onwards. So let's show an example of radix sort. So I'm going to have some numbers: 127, 52, 8, 40, 3624, 1097. Let's do like 332. Okay, so this is our array, right? Or this is the array of values that we have. So the first thing we're going to do in radix sort is basically we're going to create a list of buckets. Or no, that's not. Okay, so the first thing we do when we have this radix sort is we're going to pay attention to the first least significant digit. So this 2, the 7, the 2, the 8, the 0, the 4, the 7, and we're going to sort by that. But how are we going to sort by that, you may be asking? Well, we have outside this array we have another nested array, which is we call the buckets array. So the buckets array looks like this. It has an array for the 0th place, an array for 1, an array for 2, an array for 3, all the way up to an array for 9, right? So in this array we can store any possible digit value. So essentially what we do is we look at this digit, like this is 2, so we take that number 333 and we put in the 2 bucket. We take the 7, we put in the 7 bucket, somewhere in here. We take this 52 and we put in the 2 bucket. Okay? Alright, it's going away. Okay, there we go. So let's do that real quick with our values. So first of all, we have the 0 bucket, which is going to take in, it's going to look, see that's not 0, that's not 0, that's not. Or well, actually this is how it works. I'll do it like this to show you how it actually runs. 0 bucket, I'll give some room for a 1 bucket. I'll give some room for a 2 bucket. And sorry, this might look a little bit ugly. We're going to go all the way up to 9. Okay, these are our buckets, right? So first we're going to take 322. That has the least significant digit of 2 because we're starting by looking at least significant digit. So you're going to place it in the 2 buckets. So 322 is going to go here. Next we're going to look at 127. That has the least significant digit. Or then we're looking at right now 7, right? Because we're looking at least significant digit. So we're going to put that in the 7 bucket. So that's 127 in the 7 bucket. Just like that. Okay, moving on, we have 52. 52 is least significant digit is 2, so we're going to put that in the 2 bucket. We have 8. 8's least significant digit is 8, so we're going to put that in the 8 bucket. 40's least significant digit is 0, so that's going to go into this bucket. 3624's least significant digit is 4, so that's going to go in the 4 bucket. And then lastly, 1097's least significant digit is 7. That's going to go in the 7 bucket, so 1097. So you can see we just went in order of each number, and we took this, and that pretty much represented which index or which, I guess, nested or inner array they fell into. Like which inner array they fell into was based off their the significant digit. The next step is we're going to correlate this back into our actual array. So what does that mean? We're going to pretty much do a loop, an iteration. We're going to loop from 0 to 10 to represent, so that way we're going through every single possible bucket, right? And we're basically going to say we're going to take all the elements in that bucket, and then we're just going to add it to our array. Or more specifically, we're going to just set array I to that. And we'll dive more into this in code. I just wanted to give you a semi-understanding of how it's actually going to work. But let's do that right now. So we're going to take that 40 is going to be here. Then there's nothing in 1, so that is skipped. Then we're going to have 322, 52, 3624, 127, 1097, and then we're going to have 8. So you can see we have a lot of empty buckets with no values, but also you can notice with this final, or this next array, not final, that the elements are sorted by their least significant digit. So now we're going to continue this process. We're going to move up 1. We're going to look at the tens place now. And for elements like 8 that don't initially have a 10 or a clear 10 place defined, it's just 0. Okay, so let's do the bucket thing again. I'll only make the buckets we need, right? But we don't need a 0 bucket, but we need a 2 bucket. So I'll make a 2 bucket. We need a 3 bucket. We need a 4 bucket. 5. We need a 9 bucket too. I'm simplifying it because I don't want to make every single bucket every single time. Or I mean, in the real array we would. In the real array we have every single we do have every single bucket every single time. But because I know what the elements are beforehand, I can just do stuff like this. Anyways, right? This is just for simplification for our visual purposes. Right, so let's sort it. 40 is going to go in the 4 bucket. 332 is going to go in the 3 bucket. 52 is going to go in the 5 bucket. 3624 is going to go in the 2 bucket. 127 is going to go in the 2 bucket. 1097 is going to go in the 9 bucket. And then lastly, 08 is going to go in the 0 bucket. So yeah, you can see, and we obviously have like a empty bucket 1 here, and empty bucket 6, 7, 8 here. I'm just not showing them because they're unnecessary. Okay, cool. So we're going to do the same process again, where we're just taking all this and putting it back in the array. So now our array is going to look like something like this: 8, 3, 6, 2, 4. And I'll actually leave in this value. And I don't like the 0. Let's make a different 0. Okay, cool. 3, 6, 2, 4, 1, 2, 7, 3, 3, 2, 4, 0, 40, 52, and lastly 1, 0, 9, 7. So as you can see here, everything is sorted by its tens value now. Highlight that. Okay, we're going to continue this with the hundreds place now. So now we're going to take this array. Let me unhighlight all these values. Oh, well, I can't unhighlight anymore, bro. Okay. And we're going to look at the hundreds place now. So we're going to look at this 0 here. I'll just delete this 8 and replace it with a new one. I don't like that red outline. So we're gonna use this 6, we're gonna use this 1, this 3. It's gonna be 0 here. We're gonna look at this, it's gonna be 0 here. We're gonna have this 0 as well, right? Because this is a 0. Okay, so what? Our buckets will look something like this, right? We have a 0, we have a 1 bucket, three, 6, and that's it. Right, so I just skipped the unnecessary buckets, like we don't need a 2, 2 is going to be empty, 4, 5 is empty, with me 7, 8, 9 is also going to be empty. So let's just go through this now. I see this bucket, or 0 is going to contain the 0, 0, 8. Then we're going to add 3, 6, 2, 4. Then we're going to add 1, 2, 7. Next we're going to add 3, 3, 2. And we're adding them to respective sub or inner arrays. Then we're going to add 40, or in this case 0, 4, 0, right? Then we're going to add 0, 5, 2. Then we're going to, this one's actually kind of big. Let me just like really just focus on this portion of it. Let's just do something like that. It's fine, it's fine. 0, 9, 7. Like that, and then we can just 7, this, like this. There we go. Okay, cool. I feel like I've forgotten the value. Did I have a problem with that? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay, cool. Yeah. So all of our buckets are sorted. We're going to move on to the next step. We're just taking all this and putting it into an array. So that's going to be 0, 0, 8, 0, 0, 0, 4, 0, 0, 5, 2, 1, 0, 9, 7. Then we're going to look at 27. Or 27 is going to be added. Or set, not added. We're setting these values in an array. It's the same array, we're just setting these values. Okay, cool. So now you can see that our array is now sorted with the hundreds place in mind, right? 0, 0, 0, 0. Oops, did not mean to fill the inside. Is that? Oh, I forgot the 1. Oops. 127. I was about to say, why is 27? Like that. 3 and then 6, right? So it's sorted by its hundred place. And now we're going to go to our last iteration. We're just going to be looking at everything from the thousands place. So we just remove all of the stuffs, all the highlighted zeros from all of y'all. We can focus on the thousands place. That's going to be a 0 here, 0 here, 0 here, a 1 here. This should be 1, but yeah, and then a 0 here. A 0 here, and then lastly a 3 here. Okay, so what we're going to do now is we're just going to take these values, same process, bucket them. So I have a feeling that 0 buckets could be huge, so I'm just going to make like this. You know, 1 bucket, and then we need a 3 bucket. And if I'm not writing any buckets like the 2 or stuff, it's not because they don't exist, they technically exist, but I'm leaving them out because they're going to be empty anyway, so. But anyways, right, so you're going to add a 0, 0, 8, or 0, 0, 4, 0, or 0, 0, 5, 2, then we're going to add in our 1097, and I'm actually just going to take this section of it just like this. Okay, so then we're gonna add a 0, 1, 2, 7, and a 0, 3, 3, 2. And then lastly, we're gonna add in our 3, 6, 2, 4 here. So when we kind of debucket all this and set it back into the array, we're gonna get a 0, 0, 0, 8, a 0, 0, 4, 0, 0, 0, 52, 0, 1, 2, 7, 0, 3, 3, 2, 1, 0, 9, 7, 3, 6, 2, 4, and then you'll notice on top of it being sorted in the thousands place, right? Every element is also properly sorted. So as you can see, we've fully sorted the array. So if I were just to write the array out in layman's terms without all of these extra digits, it'd be 8, 40. Our final array from this process would look something like this. Right, so some key takeaways to understand from this sort is that as we loop through the process, we're going to essentially be sorting by the ones digit, then the tenth digit, then the hundredth digit, as you can see here, and then lastly the thousandth digit, right? That's really what's going to come down to. If you're asked to trace this no buckets, it'd be pretty straightforward, right? You would just sort by the ones digit, as we did. Then you sort by the tenth digit, as we did. Then you sort by the hundredth digit, as we did. And then you sort by the thousandth digit, as we did. And then you get your answer, okay? And one more thing I want to explain is when we decide when to stop our loop, or how maybe what this would look like in code. Well, obviously you could kind of, or maybe not obvious, okay. You're gonna need one loop. So we need a loop to initialize our bucket array, fill those empty buckets. We're going to need another loop to assign the bucket values. So I can say assign bucket values. And then we're going to have our last loop, or kind of like put values in the array. And I'm going to replace this put with set, because we're not adding in our array itself is going to be a normal array, so we can't add. Alright, we're just going to set the array set index I to the corresponding value. And then also you see how we're repeating this process, right? Well, we're repeating this process by, this time we did 4 iterations, right? So 1, that means we're going to have some big outer loop. But also you can tell that the amount of times we loop is pretty much the amount of digits in our biggest number. So what would it actually look like? Well, our outer for loop, I can just write like here, it's going to look like this. So something like int. And people call this places is equal to 1. Because we start at 1, because the ones place is LCD, right? Is least significant digit. And so maybe I think I'll actually call this place set of places. Maybe it's places what people normally call it. Anyways, so we're going to check if, and this looks a little bit funky. This is something you haven't learned yet. Essentially, we're going to take the maximum value. So collections dot max of the array that we're going to pass in. We're going to take this maximum value. Next, we're going to divide it by places, or by place. And then we're going to modulo 10 back. I'm going to see if this is greater than 0. And then lastly, we're going to update place times equals 10. So let me just show you this an example, right? So with our code, our maximum value would have been 3624. So yeah, over there, right? Let's go over here. Let's do a bit of scrolling. So if we're to do this, our first time will come like this, right? 3624 divided by a place of 1 modulo 10. Well, this is the same thing as just saying 3624 modulo 10 is 4. Is 4 greater than 0? Yes. Okay, moving on, right? We do 3624, divide that by 10, modulo that by 10. That's going to give us 362 modulo 10. Or here, I'll write the same part with the other one. That's going to be the same thing as saying 362 modulo 10, which is equal to 2. Is 2 greater than 0? Yes. Keep going. So we're going to keep going. We're going to do 3624 modulus 100. Divide that by 10. That will give us, divide that by 100 is going to be you 36, I think. Yeah, 36.24, but the 0.2 gets truncated off. Truncation. We're going to modulo that by 10. That's going to give us 6. Is 6 greater than 0? Yes, keep going. So now we're going to do 3624 modulus 100, or modulus 1000, or sorry, divided by 1000. The same thing as 3 modulus 10 is 3. Is 3 greater than 0? So this, keep going. And then so lastly, we're going to try and run 3624 divided by 10,000. And well, this is 0. And then 0 modulus 0, or modulus 10, is 0. So 0 is not greater than 0. So stop here. So you can see it runs our first iteration, our second, and then our third, and then our fourth, just like we wanted it to. Alright, real quick, there actually is no place. Modulo 10. I luckily just realized that right now when I was doing this. Okay, so our code's gonna look something like this, right? So essentially, if you're kind of confused how this works, it's like our biggest value, which is 3624. Let's just run through it. In the first iteration, we're going to do 3624 divided by 1, check if that's greater than 0, which it is, because 3624 is greater than 0. We're going to do 3624 divided by 100, or by 10, which is 362, and 362 is greater than 0. We're going to run that again, 3624 divided by 100, which is 36. So this is looking at 364, this is looking at 362, this is looking at 36. 36 is greater than 0. We're going to run this one more time with the thousands now. It's greater than 0. Well, that's true. That's just going to be 3 we're looking at. But then, when we run it again, and we try to do 3624 divided by 10,000, right? See, this one works. It's greater than 0. That's going to be false. So you can see that we'll only go through the iteration 4 times. And what did we do in our code? We only went through the iteration 4 times. So that explains that. I think that's probably one of the harder lines when it comes to this. So yeah, let's get to actually coding our Radix sort. It's gonna be the last sort we need to code for UILCS algorithms class I have. So it's gonna be a public static void. I'll call it Radix sort. It's gonna take an integer array, and that's all I need. Create our initial loop. I is equal to 1, and we'll call it place. 1. We're gonna do collections dot max array. I need to import, could import it for me. My bad place is greater than 0. Well, this condition is true. Oh, also I forgot one thing actually. My original statement is wrong. It should be erase.toList ours, just like this. And we need to import. Okay, there we go. This is not importing arrays. I'm pretty sure this is a method. Oh, it's as list, bro. Freaking. Okay. Sure, pop off, I guess. Whatever you want to do. Oh, then we can just do this. Integer. Okay, boom, 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 boom. I'll explain this line a little bit later. Place times 10. Okay. So, and yeah, sorry that I have to update that line. But anyways, the rest of the loop should be pretty straightforward. We're going to create an array list that'll store in itself array list of type integer. And this is going to be called our buckets. It's going to be equal to new array list, just like this. So we are going to go from 0 to 10. This is going to be our initialize buckets. Said we'd have one of these. I think I forgot I there. Okay, so we're gonna say buckets dot add at index I, or we don't even need to do that. We can just do add new array list, just like that. That's gonna fill our bucket. So our bucket will now look something like, I guess because we store. In fact, I'll use this. It looks something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, left 10 empty arrays in it waiting to be filled. Right? We said that'd be for the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 respective digits. The second loop is going to set, or I guess you can kind of fill bucket inner arrays loop before in I is equal to 0. Just say while I is less than r.length, because this loop we're looping through every single one of our array variables. We can do buckets dot get, and it's kind of unique. So we want to take the array element modulo by 10. Array element, not just modulo by 10, but array element divided by place modulo by 10. And then at that particular location, we want to add in our array element. So what the line will look like. Okay, maybe that one's going to need some explaining too. And our last step is going to be the same as the other one, or same, so that's just going to set our array to new values. So we can loop from an integer that is contained in our buckets. And this should probably be int. So we can handle, or sorry, that's not what the issue is. The issue is this should be get I. Yeah, there you go, this works. And but this can be int. I was writing integer to keep in team with this stuff here. I don't want to write int to confuse you, but I could shell int also works because of auto unboxing. I made a video on unboxing if you want to check it out. It's in the primitive types video. No, so we're going to set array at I is equal to none. Okay, so this is it for radix sort. Let's go up here. Let's call it radix sort. What was our array again? It was 322, 127, 52, 8. So just 322, 127. That's all I got. 52, 8, 40. Then we have 3624 and 1097. So 3624, 1097. Radix sort will needs this array type integer. Can we just run this? Will it cook us? Okay, so no, because logically it makes sense to pass in an int array. Okay, then we won't use this idea. We can make a get max function that will take in the array. So we'll define this helper method over here. So say public static int get max, take in an integer array. For an r is less than r.length. This is a pretty. I'm not gonna explain this one too much. Int max is equal to r 0. I'm just gonna say if r I is equal to max, then we want to set max equal to r of I. This should be this. And then we're going to return max. Okay, cool. That'll handle that for us. I wanted to use the collection stuff because I think that's cool. But I think the issue with that is because it's generic, then generics expects things to be in all wrapper classes. But no one's willingly going to pass an integer array, like of all cattle integers. No, I don't think many people are going to be typing this out when they want to use the function Radix sort. Okay, so let's run this. Scroll left for the reveal. Uh-oh. Okay, I must have made a mistake somewhere. It says line 167. Let me see, there's been an issue with my indentation. Okay, this should be right. That's right. Wait, is not everything right? It looks like we're leaving things right. So bucket length of 10. Would this do anything? I don't think so. Right, so it's just probably here. It's taking an array. Oh, okay. Yeah, my fault. Let's just. We have to define something right here. I'll call it IDX, and we'll do IDX here because when we're going through this loop, right? Your array is probably not going to have 10 different distinct elements like mine doesn't, but your bucket sort has 10 elements. So technically what we're doing here is if we set this I, we're eventually going to reach i's like 7, i's like 8, i's like 9. They don't really exist in our array. So by creating an integer IDX and storing outside and only updating it here, right, we're essentially saying, okay, look, if there are elements for me to receive, then fill that in my array, right? And we know the amount of elements that are in buckets is the same amount of elements that are in the array because we're not creating or deleting any arrays, right? We went through that whole process. We're using the same number of arrays the whole time, right? But that's why we can say that this will work, and so we can say this will work. But saying putting it to I will not work because I goes greater than 6, which in this case is our array, or yeah, 6, which in this case is our array length. Or well, 7 is our array length, so 7, yeah. Okay, so let's run this now. And yep, you can see that the array sorted perfectly, right? So let's explain some weird features about this. First of all, well, now I've simplified this. I don't think I need to explain this line, but this line here I probably do need to explain. So what's going on here? So I said that, remember, when we're doing this, let's look at something like here. The buckets that we went to were chosen by this value, right? 8 went to this bucket, or let's look at the first instance, right? In this first initial one, we looked at the least significant digit. 2 went to this bucket because its least significant digit was 2, 7 because of that, right? In this one, 4 went to there because its second least significant digit was 4. This one was 3, and so on and so forth. So how do we actually get that in code forms like this? This is the exact same thing. Think about it. If your array is 1, right, if I look at that line, Ri divided by place modulus 10. If we took something like 40 and our R is 1, then that's a modulo 10 is going to give us 0, which is where it ended up, right? Or let's do something big like what we had 364. There's different values in every place. If we do 364 divided by 1 modulo 10, that will give us 4, right? Which is where our least significant digit, that's where it should go in the first time. If we do 3624 divided by 100 modulo 10, or why am I jumping the gun to 100, bro? Yo, it's just 10. That when we divide by 10, you're gonna see that we're gonna get, well, if I can draw 10 correctly. Right, okay, boom. We are going to get 362, chunk it off to 4. It's gonna give us 2, right? So then again, you see how we're looking at this value now, sorting by the tens place, which is what we want. The bucket is gonna go, or we're looking at this number, we're gonna assign it to bucket of index 2, bucket 2, right? Which is what we did. Let's keep on going. Let's do 3624 divided by 100. 100, yeah, 100 modulo 10 is going to give us 6. And lastly, if we do it for 1,000, so 3624, 1,000 modulo 10 is equal to 3. So you can see how this actually is going to be giving us each of our values that we want for our different buckets. If it is something like 8 or something, like let's say we're looking at 8 at the tens instance, this will give us the right bucket of 0 because 8 divided by 10 is 0, or this is integer division, and 0 modulus 10 is 0. That's why we get 0. That's why we can say all of this stuff. We're getting all zeros. Okay. So that's probably that feature explained. That's definitely the hardest aspect. It should hopefully make sense. The reason we're having this out of for loop that confused me at first is because think about it, right? We're going to be looking at this inner for loop and we're going to be getting each value out of our bucket, right? Our bucket has 10 digits. If we set this to r.length, just see, or set this to r.length, we only go up to like bucket 7 or something, right? But what about buckets 8, 9, and 10, right? If we have all these buckets past 7 that we miss, or we don't have a bucket 10, but you get my point, right? Which, first of all, that's why we set this to 10, so that's why, so that way we can look at every single bucket. Now we need this idx variable because when we go through this, if we set this to I, right, like I did initially, a mistake, right? We're gonna, if our array has 7 elements like ours does, then we're gonna have an index out of bounds except array, or index out of bounds error. That would be an exception, not an error. That's an important distinction. Right, we have an index out of bounds exception because this is 10. So we have this in IDX, and then we're going to increment it by 1. Just keep track of which element we need to increment. Or just keep on track of which position we are in our array. Hopefully this makes sense. I think you've seen stuff implementations like this before, where you have an IDX and like I'm sure in like your coding classes. But also this is just like plus plus we explained in a different video. All this is really doing is like, okay, I found, let's say it finds an error element, right? It's gonna assign that to index 0. So I'm gonna take that element, put it in index 0. Then the next time it finds an element, so if it, let's say it passes like 4 different empty buckets, so it finds another one. It's gonna set that to index 1. Then let's say it passes 2 more empty buckets or something, index 2. Maybe in that same bucket it finds another element, index 3. You can see how it's with this IDX system, we don't have to worry about the empty buckets, and everything just kind of goes into order. Okay, cool. Hopefully that makes sense. Again, if you have any questions, let me know. If you're confused on how this get max function works, I can explain it real quick. We're setting the max value to the initial array element. Basically, we're just going to loop through the array and say if we find a value that is bigger than our max, make that a new max, right? And then just return that value. But that is bucket sort and, or sorry, not bucket sort, it's Radix sort. It's similar to, I say it's similar to bucket sort though, because people use buckets, but I haven't learned bucket sort yet, so I can't differentiate it too well. That is Radix sort, but of course it can't be a sort video without going over the time/space complexity. Why am I going over this? Because this is really what UIL loves to test you on. Like they might throw a question. I don't know the last time I saw when it's like trace the sort or something like that, but they will ask you about your time/space complexity. More time than space, but they could add there, it's free game for them to ask you about space. So your best case is looks a little something like this. Your best time complexity is O of ND. Your average is O of ND. And then your worst is O of ND. And it's not really O of ND. The reason why we say O of ND is because we have multiple for loops, right? Multiple loops. But really, you can simplify all of these down to O of N, O of N, O of N, if you wanted to. D here represents digit, okay? If your biggest number is 4 digits, you can have 4 iterations of, you're gonna go through this O of N, right? This is, if you kind of view going through all of this as one O of N, and you're going through all of this 4 times, so that's gonna be 4 O of N's, or 4 times O of N. So that's where that comes from. But you can also simplify this down to O of N if you would like. That's allowed. I'm showing you O of ND because they might ask for that. Space complexity, see if we can fit it. Best is O of N plus K, which again can be simplified to O of N. Average is O N plus K. And then lastly, your worst is going to be O N plus K, which again can also be simplified down to O of N. O of N and O of N. Okay, so this was word sort. Sorry, Radix sort. I don't know why I have word sort on the mind. Thank you for watching. I'm gonna have one more video over sorts, and not over any new algorithms. I'm just gonna go over every single time/space complexity again in one general video, because I think that's the most important thing to know about these sorts.